Question 28. You work for a company that produces electronics with integrated circuits. One of your products is called a shift register. This product is designed to automatically shut down if its operating temperatures exceeds 175 degrees Celsius. The manufacturing process has been designed to have a standard deviation of 0.4 degrees Celsius. You test a random sample of 19 shift registers and you record the following shutdown temperatures. Construct a 98% confidence interval for the overall mean shutdown temperature. So the first step here, I need to compute the sample mean in order to be able to compute the confidence interval and everything else. So I'm just going to copy this and I will paste it into an Excel sheet. And I'm just going to double check the sum. At the very bottom here, it is correct, so I'm just going to find the average. So the sample mean is equal to average of this data. Now, we need to compute the standard error, or else known as the standard deviation of distribution of sample proportions. So the standard error is equal to the population standard deviation divided by square root of the sample size, which is, in this case, standard deviation is 0.4 and the sample size is 19. So this is going to be equal to 0.4 divided by square root of the sample size 19. So that is the answer here. So that is the first answer that I can double check with the question, which is the standard error. Now the critical value in this case, despite the fact that this is estimating a population mean, but the fact that we still have the population standard deviation, that will leave us with the fact that we can actually compute the Z critical, not the T critical. So I'm just going to do that. I'm going to go to compute critical values and I will use the normal distribution. So normal distribution. And in this case, as you can see here, wait a minute here, T distribution, normal distribution. Okay, so this is the normal distribution, and I know that the level of confidence is 98. That's all I need. I don't need the degrees of freedom, so I'm going to calculate that, and that is basically the critical value. So that is the critical value. I'm just going to plug it in here, and I can double check my answers before proceeding. If I don't have the population standard deviation, then I will compute the sample standard deviation from the sample, and then I will use the t-student distribution to figure out the critical value, and I will plug the degrees of freedom in this case, which is 19 minus 1, that is 18. And then I can compute the critical value. Notice here that the critical value is not very different. It's not too far from the Z critical value. The T critical value is not too far. So that means I can use the T estimate of a mean, and the answer is not going to be dramatically different. So what I do have here, I need the sample mean, so I'm just going to copy the sample mean, and I will head to the calculator, and I will use the sample mean right here, so I'm just going to paste it. Because we don't have the sample standard deviation, I'm not going to compute the sample standard deviation. I will just substitute that with the population standard deviation. The sample size is 19 and the confidence level is 98, and then I will use the upper bound and the lower bound to answer that question. You get the idea. So that is the lower bound, and this is the upper bound of the interval. Okay. Sorry, my baby just woke up and she's not happy. I hope this question is clear and how to answer it is clear. If you have any questions, let me know.